Now, let us look at differentiation using logarithms. So, we use logarithms in differentiation when the function f of x and y is equal to function f of x is made up of products of various functions or quotients of various functions or some function power some functions. So, we use logarithms when we have product, quotients and powers of lot of functions. For example, if you have y is equal to sin x power x and you're asked to find dy by dx. So how do we think? How do you think we can do this? So should we use formula x into sin x whole power x minus 1? This is something power x, something power x, or sin x power some number, x into sin x power x minus 1 into sin x's differentiation is cos x. So some of you might think that this is the answer, or some of you might think this is of the form is like an exponential form. So this is sin x power x times log of sin x. Sin x power x times log of sin x, because the differentiation of x power n is n times x power n minus 1, and the differentiation of a to the power x is equal to a power x log a. So if you have sin x power x, which of these two formulas should be used? So the answer is not this formula, not this formula. None of these can be used. So x power n formula can be used if the base is a variable and exponent is a constant. Base is a variable and exponent is a constant. You can use the differentiation of x power. A power x exponential differentiation can be used if base is a constant and exponent is a variable of x. So if base is a variable, exponent is constant, we can use this formula. If base is constant, exponent is a variable, we can use this formula. So if base as well as exponent are variables, are functions in terms of x, you cannot use these two formulas. So in these cases, logarithms will be useful. So how we do this is, so first let us apply logarithm on both sides. So ln y will be equal to, so what is ln of sin x power x? So we know that by the properties of logarithms, x comes outside, which is equal to x ln sin x. So ln y is equal to x times ln sin x. So now I'll differentiate both sides with respect to x. So d by dx of ln y is 1 by x dy by dx, sorry, 1 by y dy by dx, 1 by y dy by dx, 1 by y dy by dx is equal to, here you have a product of two functions. So we can use the product rule, right? So x times the differentiation of ln sin x is 1 by sin x times sin x's differentiation is cos x, plus ln sin x times the differentiation of x is 1. So this implies dy by dx is equal to, if you do the cross multiplication, y is nothing but sin x power x, sin x power x times x cos x by sin x is cot x, x cot x plus ln sin x. So this will be the differentiation of sin x power x. Sin x power x times x cot x plus log sin x. So whenever you have a function made up of two functions, the power of one another. So we cannot use the differentiation of x power n or a power x. We have to go to logarithms and follow the process. So let us look at some more examples where using logarithm can be beneficial.